New Jersey Governor School of Engineering and Technology 2015 Final Symposium.
My name is Miku Fujita.
I'm Sirius Just.
I'm Victoria Liu.
I'm Andrew Tabantabai.
And my name is Samantha Young. Our research project is Babel Fish.
So to briefly go over what we're going to discuss, first we're going to start off with the background of the project. Then we'll talk about the design process and give you a quick demonstration. Then we'll talk about our future plans, and finally we'll end with our conclusion. So what exactly is a Babel Fish? Well, the name actually came from the science fiction novel, The Hitchhiker's Guide to the Galaxy. And in this novel, there's a fish that you can stick into your ear, and it can translate between any two languages. So our vision was to create something similar to the Babel Fish that was described in the book. And so we wanted to create an accurate translator that breaks the language barrier and was also intuitive and very portable. So Babel Fish would be supremely helpful in a variety of different occasions. For example, for me personally, when I traveled to Spain several years ago, I had trouble communicating with a taxi driver, which led to a miscommunication. And so if I had had a Babel Fish, that would have facilitated fluid conversation and just overall improved my travel experience.
Our project sought to ameliorate language barriers. With rapid globalization, foreign collaboration, and immigration, people of different cultures and languages struggle to find common ground, which may result in desperate situations. When it comes to healthcare, immigrants often have difficulties describing their symptoms to doctors, which can delay or negatively affect treatment. Language barriers become a serious detriment when it comes to day-to-day communication, job interviews, tourism, and advertising. Luckily, research demonstrates that machine translation is a feasible option to overcome this barrier. Translations were done using application programming interfaces, or APIs. APIs involve accessing web-based software applications and using them to power products. The APIs used in Babel Fish were the Google Speech-to-Text API and Microsoft Translator API. Although both APIs are free, Google API only processes 50 requests a day, and Microsoft API only processes 2 million characters a month.
For this project, we used a Raspberry Pi 2 Model B. It is a portable microprocessor used a lot by hobbyists for a variety of purposes because of its portability and relative inexpensiveness. It has USB ports, which we use to connect it to the Wi-Fi and a headphone, and it is charged with a micro USB charger.
The overarching goal for this project was to create an accurate, intuitive, and affordable universal translation device. The goal for user convenience was to ensure that the user could easily learn and use the device. The goal for affordability was to keep the cost of the device low enough so it could be accessible by many people. The goals of the project were achieved by following the engineering design process as shown above.
One challenge we faced was deciding how to implement the speaker and microphone into our device. So we decided to create a decision matrix, and we decided on 5 options. And our final decision was on the speaker and mic combination because of user convenience and portability, which were our top 2 priorities. And we also created a decision matrix for the user interface. So we were deciding between a 1-button system, 2-button system, 5-button system, and a dial system. So we decided on the 5-button system for the same reasons, the user convenience and the portability, which were our top 2 priorities over the ease of programming and ease of assembly because we wanted the user to have the best possible product.
The 5-button system was further evolved into a 4-button system with the idea that fewer buttons would increase usability. In the final design, we included 2 buttons for language selection, one for selecting and one for scrolling. 3 LEDs so that the user was able to identify which languages that they had selected, and 2 further buttons for recording, one for user A and one for user B. Furthermore, there's a microphone located at the top of the device here so that the users can speak into the device without excess background noise, and a speaker in a neutral location on the top of the device so that both users can hear the translations clearly.
During the design process, special consideration was given to user convenience. As seen in the diagram above, the curved design of the device provides the user with a firm and comfortable grip. The microphone located at the top allows the user to speak into the device and pass the device like a microphone in an interview. The language selection buttons are strategically placed so the user can hold the device and use their thumb to select between languages, and the LEDs clearly display which language has been selected.
The final design was CADed using Autodesk Inventor. We decided to split the design into two sections, a top lid and a bottom casing. The bottom casing has a hole for a removable battery pack, so that if a battery were to ever die or to there to ever be a problem, the user could remove the battery and change it out. There's also several supports located throughout the device. These supports are to keep the sensitive electronics, like the Raspberry Pi and the circuits, in place. It's very important that these do not touch each other to make sure that shorts do not occur, which would cause problems with the device. There are holes in this casing to allow for the buttons and the speakers and the microphones. The final prototype was printed on a MakerBot 5th generation using PLA plastic. MakerBots use a form of additive prototyping known as fused deposition modeling. Fused deposition modeling is when a heated extruder pushes filament onto a platform in individual layers, creating a 3D model. This is our final prototype. And this is how it works. The user first locates the back of the device, and on the back of the device, there is a switch. There's an on and off switch located here. So say you were in another country and you were really hungry. Hey, how much does that apple cost?
Lo siento, no hablo inglés.
Well, I speak English and he speaks Spanish. So what you would do is you would go to the front of the device, and there is language selection here. This button is for selecting your language, and this one's for scrolling. So I would select my first language, English, and my second language, which is the second LED, Spanish. Since I'm the first user, I would click this button to speak into the device. How much does an apple cost? And then it has to go through all of the APIs so it can translate. It's translating.
Hit this button. Did you actually select this?
Yeah. How much does an apple cost? All right. Well, it translates using Google APIs. And so I would say, how much does an apple cost? And then it would speak out of this speaker here in Spanish so that the other user can listen. So, and he would respond. I would click the other button. This is all controlled by me, so he doesn't have to get confused on how the mechanics of the device work. He would say,
$2.
Thanks to the Babel Fish, I would be able to understand what he said because it would translate back out into English for me. So, oh, $2, awesome.
Alright.
I'll take 2. And it would say it back out in Spanish.
Okay. Do we have the video?
So this is a picture of our final prototype. All of the electronics are enclosed within this case here.
So for this project, we expanded on an open source software provided by the MakeScene website, and that was great because it provided us a solid foundation, which sort of worked, but it had some limitations. It wasn't user-friendly. It required a monitor and a keyboard to use, and it didn't work in the current version of Python. So we had to convert it to the Python 3. Then we added a UI for a more friendly user interface. We also split it into four modules. The first one allows the user to select his languages. The second one allows the user to record his voice input. And the third one translates that input into text. The fourth module then translates that text into speech in another language. To accomplish this, we used the Google text-to-speech, speech-to-text API, and the Microsoft translation API.
So the Raspberry Pi was used in combination with a variety of circuit components along with the program to make the final Babel Fish. So the Raspberry Pi is a microprocessor, which means that it has all the capabilities of a computer. And it also has 40 GPIO pins, or general purpose input-output pins. And we used 3 different types for this project. The first is the 3.3 volt, which provides constant 3.3 volts to whatever is plugged into it. Then we have the ground, which is connected to 0 volts, and finally the general GPIO pin, which for this project was used for reading voltages. Next, we'll discuss the circuitry. So we use two different types of circuits in the Babel Fish, one for all of the buttons used and one for all of the LEDs used. So the button circuit that started off with a 3.3 volt GPIO pin, then went to a 10 kilo ohm resistor, then to a push button which when pressed connects the circuit and allows current to flow, then to a GPIO pin. Then the LED started off with a general GPIO pin, then connected to a 220 ohm resistor, then to an LED, and then to ground. And we made all these circuits first on a breadboard, which is used for creating experimental circuits to make sure that everything was working. And then once we wanted to finalize it, we soldered everything.
There are several ideas for the future of Babel Fish. So the first idea is to extend the language options to all modern languages using an LCD screen, so the user could simply just scroll through the screen and pick their target languages. The next idea is language detection, so the user would not have to input the target languages into the device, but rather the device would automatically detect what languages the users are speaking. The next idea is real-time translation, so getting rid of the lag that the device currently holds, and this would allow for more fluid conversation. The next idea is unlimited conversation exchanges. So currently, the device is limited to 50 conversation exchanges per day, but by making it unlimited, the user would be able to use the device all day for as much as they wanted to. And our last idea is mass production and distribution of the device using injection molding rather than fused deposition modeling, which is more cost efficient when mass producing.
So the purpose of this project was to make a more usable, portable product that's a lot more user-friendly. And I think we've succeeded in creating that, as well as an accurate translation device that could help make the world a smaller place.
So we'd like to thank our project mentors, Mr. Anson Jacob, Mr. Joseph Marizio, Mr. Daniel Moskowitz, and Mr. Michael Vanasis for guiding us through this project. We'd like to thank our residential teaching assistant, Nitika Yadlapali, for supporting us throughout the project. And we'd like to thank Dr. Rosen and Dean Antoine for putting this project together. We'd also like to thank our sponsors for making this project possible. Thank you. Does anyone have any questions?
How's the connection to Google made, like currently?
Over an internet connection. So it would basically it would send a call to the Google API through the Wi-Fi.
So it has a Wi-Fi interface right now?
Yeah.
What makes the device limited to 50 conversation exchanges per day?
Microsoft only allows 50 conversation exchanges.
Does it work over cellular? Does it work over cellular?
Currently, this device does not have cellular capabilities. However, in the future, we would like to see Babel Fish having cellular connections so that it could be tethered to your phone and more portable for the user.
Yeah, at present, why the limitation for the 50, whatever you said?
That's due to the free aspect of the APIs that we are using. If we wanted to buy access or memberships to these APIs, we would get unlimited. However, with the idea of affordability for our user, we decided to keep with the free APIs and keep the 50 per day.
Thank you. And one more question. What is the weight of this?
The weight?
Okay.
Yeah.
The wait between translating and actually speaking out is about 15 seconds usually.
Oh, like how much is the weight?
How much is the device?
The weight is less than a pound. It's relatively light and it's easy to hold in your hand.
Oh, thank you.
I get a feel at one point when you guys tested it worked, right?
Yeah. No. We have a video.
We do have a video.
Do you have video?
Do we actually have a video?
It's not in the computer.
That's fine. I mean, I was just curious. So it did work at one point, right?
Yeah.
Good job, actually. It's a good product, right?
Yes, it actually translates from English to Spanish, Spanish to English, English to Mandarin, and Mandarin to English. and any combination of those three languages.
Did you consider any other programming languages besides Python, like Java or?
Dos dólares.
Because we were using the Raspberry Pi, we decided to use Python.
It's the one button.
So if you guys want to do a super quick demo, you can put it by the microphone, but it has to be like.
Alright.
So we chose Python for its simplicity and that we had the open source available to us already. So.
Alright, so this actually is working, although only it's natural.
Oh, okay.
$2